Hi students, now we are going to understand what is the meaning of most probable velocity of the gas molecules. Okay, the gas molecules are taken in a container which is maintained at a temperature capital T. Now as I said, the velocity or the speed of different molecules will be different. But by probability, what may be the probable velocity of most of the molecules? Now if you ask the question, do you want to be happy? Do you want to live longer? Like that, if you ask the question to the public, means most people, what do they say? Yes, I want to live happily for a longer time. Some people may be having the negative tinge of life, is it not? But most probable means what? Everyone wants to be very happy only for a longer period of time. Like that, if you ask the question, most of the molecules will have some velocity that is called as most probable velocity. So it is the velocity acquired by most of the molecules of the gas. And for this, directly we can go for the expression how to find the VMP. So the most probable velocity of the gas molecules VMP is found to be 2 small kt divided by small m, and this is also equal to square root of 2 RT divided by capital M. Once again, this can be written as a square root of 2 RT can be substituted by PV, okay, as usual. So this is PV divided by capital M, and this is once again equal to square root of 2 into P is retained in the numerator and V is shifted to the denominator as M by V, so that mass by volume is equal to a density of the gas. So that this is now equal to square root of 2P divided by rho, the density of the gas. So these are all the different expressions for the most probable velocity. Now already we have understood how to find the average velocity of the gas molecules, how to find the RMS velocity of the gas molecules, and right now we have understood how to find the most probable velocity of the gas molecules. So there is some relationship because almost the same type of factors, Kt by M, RT by M, PV by M, P by rho only is there. Only the numericals value, okay, is different in this. So there may be some relationship between the three velocities. So what is the ratio of these three velocities? Let us find out. So I will summarize once again. V average, okay, V average is equal to square root of 8 by pi RT by M, and V RMS is equal to square root of 3 RT by M, and most probable velocity, once again I am rewriting here, VMP is equal to square root of 2 RT divided by M. Now this 8 by pi also can be written as 2.5. So this is square root of 2.5 RT divided by M. Now this RT by M is the same in all the three, is it not? So the coefficient of RT by M, which is greater is 3, which is lesser is 2, which is in between is 2.5. So which is the greatest among these velocities is the VRMS, is it not? So we find that VRMS is to V most probable, okay. Next one is V average is to V most probable. This ratio I am writing. So when I take the ratio, constants can be eliminated. Only the factors I am going to write. So this is now what first one is square root of 3 is to square root of 2.5 or 8 by pi, okay, is to square root of 2. So my dear students, you have to remember that VRMS is greater than V average, once again, which is greater than what V most probable, okay. So this is also written as what? This is also written as 1.732 is to 1.58 or 1.6 is to 1.414. Therefore, V RMS, this is greatest. So this is greater than V average, which is once again greater than what? V most probable. So in the competitive exams, using these expressions, there are so many numericals asked regularly. I hope you must have understood what is the comparison between the three types of velocities, namely the RMS velocity, the average velocity, and the most probable velocity of the gas molecules. Fine.